Educational Communications and this station present Environmental Directions with Nancy Perlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Perlman.
Hello. For the next half hour, we are going to be talking about our changing weather patterns and climate change in California, and also discovering the science behind California's landscapes with my guest, William Selby. He is Professor Emeritus of Earth Science, Geography, Weather and Climate, and Environmental Studies at Santa Monica College. He's been a visiting professor and former guest lecturer at the University of California at Irvine and Los Angeles. He has been a science consultant for documentaries such as Dry Times. He holds a California Naturalist Certificate and was awarded the 2025 Outstanding Educator Award from the California Geographical Society, of which he is also a member. He's a member, too, of the American Meteorological Society and Union of Concerned Scientists and the American Association of Geographers. He has authored many works, including Rediscovering the Golden State, California Geography, now in its 4th edition, and his newest book is California Sky Watcher, Understanding Weather Patterns and What Comes Next. Welcome. It's a pleasure to have you on the program.
And it's my pleasure to be with you, Nancy. Thank you for inviting me.
I was absolutely thrilled to learn about California's weather. Your book is so easy to read. It's good for scientists, but it's good for the general public to learn about why we have the seasons that we do and why we have the vegetation that we do based on the weather. But you also explain the difference between weather and climate. Can you do that for us?
Sure. Weather is what's happening now where you are. Pretty simple. Whereas climate is more general. It involves weather patterns that occur over longer periods of time, usually over larger areas.
In your book, you divided the chapters by the various seasons from summer, autumn, fall, winter. Can you explain why the weather is different in those seasons?
You bet. Of course, we're focused on California, from the Oregon border to the Mexican border, and from the ocean in the west to Nevada and Arizona in the east. And so there are so many different microclimates that we can experience when we travel across the state. So what we did in the book is, I worked with Martina Sathras, by the way, there at Heyday. I was trying to pour in as much science as I could, and she wanted me to write more stories. So we got this balance between the two. I think it came out really well. What we did is I took the reader across California during each season. So we started with summer in Southern California, where we have these supposed perfect climates, right? The mildest climates in the world, we could argue. And we took them across California all the way to the northeast part of the state. That was the end of summer. For the fall season, I started in northeastern California, and I brought the readers across California and back into Southern California during the fall season, and that included the offshore breezes that are so common during that time of year. And then it was wintertime, and so I took the readers across California from northwest to southeast, because that's generally how our rainy season develops. The big storms start coming in across the Pacific Northwest. The jet stream begins to drop south. Our high-pressure system that's protected us throughout the summer begins to disappear or move off toward the south. And that allows those storms to start swinging into California, and our winter season really gets started up in the northwest and begins to work its way south until finally we get rain in Southern California and snow in the mountains. So that's our winter season that brings us all the way down to the southeastern corner of the state eventually. And then it's time for spring. And spring develops from south to north, you could argue, because the flowers start blooming in Mexico first and work their way up into the Southern California deserts and coastal areas, and then on up toward Northern California as we get later on in the spring. And all also in elevation. So an example would be spring develops, of course, from the lower elevations up into the higher elevations as we get the snow lines melting higher and higher. And so by the time we're done with each of the 4 seasons, we've taken you across California 4 times and followed those weather patterns that really help us define what is the difference between winter and summer and fall and spring.
Should everybody understand our weather patterns?
You bet. It affects not only our plant and animal communities, but it's affecting every person everywhere on this planet and in this state.
When I listen to the news, I hear the meteorologists talking about the marine layer. What is that?
So the marine layer is trapped under our high pressure systems. It's that cool, dense, moist sea breeze that sneaks under those fair weather high pressure systems. It's very dull. It tells us that we have fair weather. It keeps temperatures nice and mild, both cooler during the summer and warmer during winter nights.
California has a broad coastline. Do the ocean currents affect our weather?
You bet. That cold California current that flows from north to south, that keeps our summer so mild. It's just the opposite of what you'll have on the East Coast, where they have that warm Gulf Stream and very turbulent weather during the summer and very steamy, hot summers as well back there compared to the coast of California.
You describe many different kinds of clouds and how they affect our weather. How many types are there?
We divide clouds into stratus and cumulus, generally speaking. That's the form of the cloud. The second way that we identify clouds is by elevation. So it can be low, middle, or high, and so we combine those, and an example would be an alto cumulus cloud, would be a cumulus cloud in the middle elevations. A cirrus cloud is a very high cloud. A cirrostratus cloud is a high layered cloud.
In addition to the wonderful descriptions, interesting stories, you also have some very useful charts that show these patterns and gorgeous photographs of some of the areas. You mentioned the wildflowers, and how can one not resist seeing the wild poppies when they come out?
Yeah, right. All of those photographs are mine except for a few. I had a little bit of help there. But yeah, one of the things I did, not only using my own photographs in all parts of the state during every season, but I also used satellite images and a few weather maps to show folks what it looked like from above when we were experiencing certain weather patterns. I think that's really important because, you know, all of this information is easily accessible. A lot of folks don't know this through the National Weather Service. I always try to emphasize this, that all of our weather information originates from the National Weather Service. It costs the average Californian about $3 to $5 per year to fund the National Weather Service, and all of the satellite imagery we get, the computer models that help us forecast the weather ahead of time, all of that is coming from the National Weather Service and the National Weather Service forecasters. And what happens then is that the news media, either on TV or radio or wherever it might be, they take this information and they make it a little bit more digestible for the general public, I guess. The point I'm trying to make here is that whatever weather information you get, and that includes that from the Weather Channel, it originated from the National Weather Service, and you have access to that information. Just go to the nationalweatherservice.gov and you'll get just about any type of weather information you want, either from the past or forecasting into the future.
The forecasting that is possible now is very useful and seems to be so accurate. I remember before the satellite days, we looked outside and we saw clouds. We said, well, it might rain, it might not. You described so many different cloud formations. Which clouds make the difference in terms of having an overcast day, having rain? How does that low pressure, high pressure make a difference with the clouds in terms of what kind of temperature we have?
Wow. Do you have a couple of hours?
I encourage everybody to read the California Sky Watcher because you do explain it, and it makes it so helpful for those of us who just sort of look outside and say, there's the weather today.
A real quick answer to that question, which there really isn't one, is that there's a very big difference between what we call flat or stratus clouds and bubbly cumulus clouds. Flat stratus clouds usually indicate that we have relatively stable weather and not so stormy, right? But the puffy cumulus clouds, the towering cumulus and cumulonimbus, those thunderheads that you see, indicate that the atmosphere is very unstable, and that is all about storm stormy weather. So those two very general cloud classifications will help us understand the weather a little bit better. Let me give you an example. When we get an overcast day and we have flat stratus clouds over us, we often get this gloomy, sort of dull gray from horizon to horizon. And the precipitation that falls from those kinds of clouds is often very misty, tiny little drops of sort of annoying mist, if you will, and drizzle. But those big, billowy cumulus and cumulonimbus clouds, they produce gigantic raindrops and sometimes hail, because up in the upper atmosphere, when those clouds are billowing up, the giant hailstones and ice crystals that form in those cumulonimbus clouds, when they're falling to the ground, they may or may not melt. But the point is they end up being very large drops of water or ice crystals. And so you can kind of tell the difference between the two various kinds of clouds just by the kind of precipitation that falls. And you can also tell whether the air tends to be stable or unstable in those situations.
You also explain how the mountains affect our weather and why on one side of the mountains we have grasslands and valleys and forests, and on another side of the mountains we have the desert community.
Right. In California, of course, this helps define who we are. You either live on the ocean side of the mountains or you live on the desert, the inland or continental side of the mountains. If you live on that ocean side of the mountains, you get a lot more moist air masses, obviously off the ocean. But you also get, generally speaking, much more mild temperatures, so that the summers don't get quite as hot and the winter nights don't get as cold. Of course, you're going to have completely different plant communities on that ocean side of the mountains. Go over to the rain shadow side, as we call it, the opposite side of the mountains facing the continent, and we have continental air masses that are very extreme. Extremely hot summer days, extremely cold winter nights, and those plant communities and all the animals and people who live there too have to adapt to these extremes in climate and the dry air as well over on the other side.
I found some of your specific examples of changes in our environment most interesting in terms of how certain places have changed in terms of what kind of vegetation we have and how important the water is, whether or not it's the Central Valley, which used to be a beautiful grassland, but the agricultural fields have changed that, and whether or not it's the Salton Sea, where the Colorado River made a big difference and barely flows into the Gulf of California anymore.
Right. Addressing the issue with the Colorado River, a lot of people might not realize that we use all of that river water now, pretty much. There's just a trickle that ends up getting into the Gulf of California where it used to flow, and there's a giant delta there and a wetlands as well that's being starved of water every year because we're diverting it to all of the different states along the way. By the way, you mentioned the Salton Sea. That was just a big mistake. Where farmers had diverted some of the water for agricultural uses in the Imperial Valley. One year, the river just decided it was going to flow through those diversion projects rather than down to the Gulf of California. And the net result is it filled up the Salton Sea. Now, of course, they fixed that. It took many months to fix that problem. But by the time they did, the Salton Sea had filled up, and it's been kind of a agricultural sump ever since. It's become a big problem. But you know what? You mentioned the Central Valley as well, and it's true that as humans have transformed the Central Valley from one of the great grasslands in North America, a lot of us called it California's Kansas, where it was a giant prairie all the way from Redding down to Bakersfield, from the Sierra Nevada mountains to the Coast Ranges. What we did is we plowed all of that up, and it's now one of the most productive agricultural regions in the entire world as well, and certainly California's breadbasket. So we changed the microclimates of the Central Valley. We pulled up the riparian woodlands and plowed them as well, most of them. And the net result is that not only is the landscape changed there, but the microclimates have changed. And that's true in much of California, where, for instance, in the Los Angeles Basin, where it used to be coastal sage and chaparral and oak woodlands and grasslands and riparian woodlands as well. We pulled all of that up and planted concrete and asphalt and apartment buildings and houses, and the net result is we have different microclimates there as well. You've probably heard of the urban heat island, and that's what that's all about, where we used to have all the natural vegetation that grew here has been replaced with our cities, and it's created much warmer days and much warmer nights in particular in those places.
You have wonderful stories in your book, The California Sky Watcher, Understanding Weather Patterns and What Comes Next, and I want to hear more about what you have presented in this great book when we return in a moment with my guest, William Selby.
Environmental Directions with Nancy Pearlman continues with further discussion of the world's critical ecological issues. For more information, you may call 310-559-9160 or go to www.ecoprojects.org. Now, here's Nancy.
I'm speaking with William Selby, who is Professor Emeritus of Earth Science, Geography, Weather and Climate, and Environmental Studies at Santa Monica College. Your book very much helps us understand our landscapes in California, the natural events, how they come about. Can you explain the weather and the climate and how that has affected us here in California in terms of droughts and heat waves, fires, floods, and other natural disasters, which really aren't so much natural disasters if we human beings have been part of the cause of them.
That's right, Nancy. And as an example, the Native Americans who lived here for thousands of years, and by the way, a lot of folks don't know that there were at least 300,000 Native Americans who lived here before the Spanish showed up, which included some of the most densely populated areas of North America at the time. And that was because Native Americans had figured out how to use most efficiently the resources that were available to them. They'd adapted to the climates and the climate extremes between, for instance, summer and winter here. We weren't so good at that. Now, give the Spanish and the Mexican era after that some credit, for they had some experience with the Sonoran Desert and other dry places. And so when they came here and invaded California, they knew about drought. They knew that water was precious, and they knew in many cases how to conserve and use water more efficiently. But when the American settlers came over, they came from much wetter climates, whether it was from places like Europe or it was from the East Coast. Those are places that got a lot of water. Water deficits weren't in the vocabulary, I guess you could say. And so they didn't know how to deal with drought. And of course in California, because we have this Mediterranean climate where strong, stable, high pressure takes over, and that stable air keeps it from raining during the summer. Southern California, we will go through periods from spring to October in many years where it doesn't rain a drop. And that's pretty typical of our Mediterranean climate here. Of course, our rainy season kicks in after that, usually, and peaks around January and February. Now, the Native Americans knew this. The American settlers didn't know how to adapt, in many cases, to this huge and this long and severe drought period. And so they have a lot of lessons to learn, and we're still learning those lessons. How to use water more efficiently and how to try to save the water that does fall in the state before it flows out into the ocean. Humans have had to adapt over time. The big problem we have now is that now that we are a little bit better at understanding how to adapt to drought, we have some of the biggest water developments in the world right here in California. We now have this problem of climate change, and it's really making a difference because what we see and what the computer models had forecast that this would happen is we see these long periods of drought that are punctuated by extreme heavy rains, atmospheric rivers, and flooding. The flooding may not last very long, but it does a tremendous amount of damage to our agricultural resources and also, in many cases, to our urban areas, and then it disappears. The temperatures are a couple of degrees warmer now than they were 100 years ago, especially during the summer, and that sucks all of the moisture, a lot of the moisture out of the soils and our ecosystems. And so you get this weather whiplash problem where a tremendous amount of biomass grows when it finally does rain. The rain quickly ends. The summer comes in warmer than it used to. What we have is what's called a vapor pressure deficit in the air. Warmer air can hold more water vapor. So in those drier higher, warmer air masses, they're able to absorb a lot more water out of the soils in our ecosystems. They dry out very quickly, and all that biomass now becomes fuel for fires. And so these are some of the changes that we are still trying to figure out how to adapt to.
Wildlife is reacting to the change in terms of climate, the weather, their resources. Animals that used to live at one elevation are having to move up to higher elevations. Which animals are suffering the most?
In general, the plant communities are moving gradually, evolving up in elevation by about 500 feet in places like the Sierra Nevada mountains. And that includes species. One particular species that's in trouble up there is what's known as the pika, or the pika, depending on how you pronounce it. It's a little animal that lives under rock formations. This animal will overheat at just mild temperatures. So they live only near the tops of the peaks of the mountains. Now, they've been migrating a little bit every year, on and off, a little bit higher. But there's a point where they can't go up any farther. There's no more earth at those higher elevations. So that would be one example of just one species that's in trouble due to the increasing temperatures.
Why are the glaciers declining?
In those increasing temperatures and the longer periods of drought that we're having, this is happening all over the world, where glaciers are retreating. Pretty much every glacier in the world, with a few exceptions. And certainly California is losing its glaciers on places like Mount Shasta and the Sierra Nevada mountains. And we can look at the before and after, and it's just so obvious that within the next couple of decades, we might not have a glacier left in California. That's the rate at which they're melting right now. There are only a few small ones left as it is.
You have been teaching about geography for many, many years. So what surprised you when you did your research for your latest book, The California Skywatcher, as opposed to editing your fourth edition of Rediscovering the Golden State, California Geography?
Wow, great question. There's so many things. Once you're out in the real world, it's full of serendipity and surprises around every corner. It's hard for me to pick one thing out. I'll just give you a couple examples of how people don't use the scientific method or critical thinking when they're trying to understand some of these issues and problems. I was giving a presentation a while back because I've been touring all over the state. A person came up to me after one of my presentations and said this: "Do you know why it only rains on Wednesdays and Thursdays?" And I was a little bit shocked, and I said, "Why?" And she said, "That's when they see the clouds." Well, first of all, there's no statistical evidence. I didn't tell her this because I tried to be kind with her. There's no statistical evidence that supports what she says. In fact, there is some cloud seeding going on in parts of the state, but not on 2 days of the week. There's another one. A friend of mine from Northern California came down, and I was showing her some of the destruction up at the Palisades from the fires from January. And we were walking through a neighborhood that was flattened. There was nothing left. Walking by one lot, there was a man standing there, and I asked him, "Was this your house?" And he said, "Yes." It was just like a giant bomb. He started talking with me. It was a terrible tragedy. I mean, he'd lost his house, raised his family there. He asked me if I believed in climate change. I was nice to him. I said, it's not a belief system. It's either we have evidence for it or we don't. And we use critical thinking to understand it better. And when I said I don't believe in climate change, he really went off on me there because he thought I was a non-believer in climate change, if you know where I'm going with this. Here was a guy who lost his house after we had 1/10 of an inch of rain between spring and the middle of January, which is the middle of our rainy season. We had 1/10 of an inch of rain. That had never happened before. He still would not even try to open his mind to the science of climate change. This scared me. Can't ignore the science because we don't like what we have to do to solve the problem. Let's accept the scientific reality, and now we can debate on how to solve these problems.
You obviously want people to learn to adapt to the natural world, to reconnect to the natural world because the natural world nurtures us. You want people to use critical thinking and the scientific method to understand our natural world. Do you think that that is happening? You have led field trips with your students to so many different places in California. Does it make a difference when they get out of the city and they see the natural world? Do they understand it better and want to preserve it?
Yeah, I hope everyone knows the answer to that question because we've all experienced this. Nature's in our DNA. This is who we are. The most important things to all of us us are whether we can get a breath of fresh air, a glass of clean water, nutritious food, shelter. All of these things come from nature, and we're ignoring them. You can't do anything in life without those basic essentials that come from nature that allow us to live on this earth. By the way, have you ever heard of the nature deficit disorder?
Please explain it.
We know that people are suffering mental illness right now, especially our young folks, because they're not getting out between the four walls. So get out there and you feel it right away. You realize this is coming from my ancestors. This is something that's inside me that you have to get out and experience if you're going to help heal yourself both physically and mentally.
And your book certainly helps us understand that natural world, because I've hiked so many of the mountain peaks, the deserts, gone to the natural areas throughout California, and I didn't understand as much of how the sky and what's up there, the clouds, affects what I'm looking at down on the ground. And you make it very, very clear, because California is a vast area of many different ecosystems. It's affected in so many different ways. We started the program with your describing the difference between weather and climate. So many people don't quite acknowledge that there is a difference and that we do have a climate crisis, and it is affecting not just the natural world, but it's affecting us in terms of agriculture, food, how we are able to live, and it's also affecting some of the other species on the planet. And you do describe some of the animals and plants that are having to adapt to different changes in the climate. So are they going to be able to do it?
Here's the problem here. Climate change has always been with us. There was climate change millions of years before people came onto this planet. There are these natural cycles. An example would be the Milankovitch cycles, which show that as the Earth revolves around the sun, changes occur in the angle at which the Earth is tilted toward the sun and the elliptical orbit around the sun. And these changes evolve over many thousands of years, tens of thousands of years. And so plant and animal communities have an opportunity to adapt to those very gradual changes. The problem with the changes that are going on right now is that we put so much greenhouse gases in the atmosphere so quickly that our atmosphere is trying to respond. Trying to summarize this for folks out there who haven't quite thought of it in such simplistic ways. What happens is that the greenhouse gases in our atmosphere are natural regulators, so that if we didn't have CO2 and other greenhouse gases in the atmosphere, we would freeze over. California, the Golden State, would be the frozen state without greenhouse gases. That's how important they are, because they allow shortwave energy from the sun to come through. That energy heats the surface of the earth and the ocean, and those surfaces then radiate long-wave energy, longer-wave infrared energy up into the atmosphere. And it's those greenhouse gases that trap that energy, that long-wave energy. So without the greenhouse gases, the energy would escape and we'd freeze over. It is really simple to understand that if you increase the amount of greenhouse gases in the atmosphere, you're going to trap more infrared radiation, and the atmosphere is going to warm up. That's exactly what's happening. Pretty much all of the Earth, from pole to pole, the Earth's atmosphere is warming, but in pockets, right? And some places are warming more than others. A few places aren't warming at all, and a few places are warming really fast. So when you average that out, it's a couple of degrees Fahrenheit right now since the beginning of the Industrial Revolution. Where I'm going with this, though, it's like you're sitting in the car on a sunny day and you're rolling up the windows. The energy can get in, but the long-wave energy is trapped and can't get out. And that's what our current greenhouse gas, or I guess you could say the global warming and the climate change, is all about right now. It's as if we're rolling up the windows of our cars on a sunny day.
I'm so pleased that you have written this book, The California Sky Watcher, Understanding Weather Patterns and What Comes Next, so that the average person like myself can better understand how the sky, the weather affects the landscapes. I wish everybody would get a copy of of this to appreciate our natural world and understand it. You have over 125 photographs, diagrams, explanatory charts. You have personal stories of your expeditions and field trips to various areas. It's a wonderful read. You certainly have shared your love affair with the sky and reveal how these changeable energies forecast the future of California's climate. Thank you so very much for presenting this information to us. Thank you for being my guest.
Well, Nancy, that means so much to me from Nancy Perlman. I can't tell you how happy I am to have had this conversation, and hopefully we'll have future conversations as well.
Absolutely. We will continuously see our natural world change and need to understand and appreciate it. I have been speaking with William Selby, who is Professor Emeritus of Earth Science, Geography, Weather, and Climate and Environmental Studies at Santa Monica College, an author as well as an educator. I'm Nancy Perlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Perlman, is a community affairs program of the nonprofit organization Educational Communications and this station.